Hi kiddos, welcome to APES exam prep number 12. This is going to piggyback on prep 11. Still talking about climate, but we're also going to talk about seasons. The key questions for this lecture are going to be: how does Earth's solar energy affect the Earth's surface? What causes climate zones? What causes seasons? How does geography impact climate? What is El Nino and La Nina, and what impacts do they have globally? So just a quick throwback into something that we talked about in last lecture, that because of the tilt of the planet and because of the differential heating from the sun's rays, we're going to have some variations in heat and temperature in different parts of the planet. And so here you can see that there's the differential heating. You've got the same amount of photons that are hitting a smaller area, whereas the same amount of photons that are being emanated from the sun here are being spread across a larger area due to this curve of the surface of the Earth. Similarly, you're going to have variations in the degree of contact with the Earth because the Earth is tilted about 23.5 degrees, and it's tilted sometimes away from the sun and sometimes towards the sun. If the northern hemisphere, I've lost my mouse, there we go. If the northern hemisphere is tilted towards the sun, then that is going to be summer for the northern hemisphere, and it's going to be winter for the southern hemisphere. So in June, summer for us, winter New Zealand, where Mr. P's parents live. Here you're going to see about equal, so that's going to be moving summer towards winter, so that would be fall. September would be fall. And then here in the northern hemisphere, we'd have winter. The southern hemisphere would have summer. And here we would have fall for the southern hemisphere, but spring for the northern hemisphere. And that's all due to the tilt of the Earth. Now, I know we've already seen this video, but I'm just going to show you a small segment of it so that we can refresh our memories about the three cells and why they're important to climate.
These circulating cells not only transport heat from the equator to the poles, but also result in semi-permanent areas of high and low pressure due to the rising and descending parts of the circulation cells, giving us our climatic zones. Where air is rising, an area of low pressure is created, so these areas see much more rainfall. This is why the largest areas of rainforest are found near the equator, and why the United Kingdom has a relatively wet climate. Where air is descending, an area of high pressure forms, giving largely clear skies and little rainfall, which leads to the desert regions. But not all deserts are hot. Antarctica sits under the descending branch of the polar cell and is also classed as a desert. With more precipitation falling in the Sahara, Antarctica is the largest and driest desert overall.
Geography can also influence climate. So although you saw that there was regions where there's deserts or regions where there's rainforests, it didn't span perfectly across the land masses, right? And that's because geography plays an influence. And one example, or a graphic effect, also known as the rain shadow effect, you have the windward side and the wayward side. So windward, wayward, and the wind is coming in, it's going to blow in cold, wet air, and warm, wet air, and as that warm, wet air moves up and over, say, a mountain, it's going to cool down, and the cool air cannot hold as much water as the warm air, so it drops a whole bunch of water right here, and then once it's light enough, it can move over the mountain. But what ends up happening is that you have a desert climate on the leeward side of the mountain. Topography, or the variation in the elevation of the area, can also influence climate. So for instance, watersheds can create regions with microclimates that are more like rainforests and microclimates that are a little bit drier. And so I wanted to introduce you to this concept of watershed. So watersheds are just giant precipitation collectors. And so if you looked at like a ring of mountains and hills and high elevation areas, that would create a watershed or a basin. And down the middle of the basin, all that collected water that's going to flow off of those elevated areas is going to collect and flow out, and that usually becomes a river. I have two videos to help illustrate the concepts of El Nino and La Nina, partially because these concepts seem to be a little bit more difficult for my students and they're much better described with animation. The first video is also kind of focused on the US and impacts the US, and the second video has a more globally aware consciousness when it makes its description. And so I wanted you to see both videos. I'd like you to record for El Nino and La Nina what happens weather-wise to the US, Asia, and South America. So if you could take a moment, get out a piece of a piece of paper and a pen, and then you can go ahead and sketch this out really fast. I'm going to go ahead and get started, but pause for a moment if you need to.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Nina, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Nina can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Nino and La Nina together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
So like I said, the second video is just as short and sweet, but has a great explanation and it's a little bit more globally conscious.
A satellite observing the Pacific zone measures the height of the ocean to monitor the El Nino phenomenon. On the satellite image, the color green corresponds to normal sea level. In the zones shown in red and white, sea level is higher than normal, which means that the water is warmer. The zones shown in blue and purple, on the other hand, correspond to sea level below normal, thus to water that is cooler than normal. The satellite image reveals that in certain years a mass of warmer water flows away from the coast of Asia to cross the ocean from west to east. Once it reaches the American coast, this water mass grows considerably in size. For months, it influences the climate of the entire region. Southeast Asia and northern Australia, deprived of the normal monsoon rains, suffer serious drought, sometimes accompanied by large fires. On the other side of the ocean, unusual amounts of rain fall on Peru and Ecuador, and hurricanes develop more frequently. El Nino usually lasts 1 or 2 years. It is followed by the opposite phenomenon, called La Nina. During La Nina, particularly strong trade winds push the warm surface waters back toward the western Pacific, which causes very strong monsoon rains in Asia, and sometimes landslides as well. To the east, on the other hand, the surface water cools, and the American coasts have unusually dry weather. Climatic disturbances caused by the El Nino-La Nina phenomenon are not limited to the coasts of the Pacific Ocean. The entire planet feels its effects.
So I hope that now you finished the content of this lecture. you will be able to meet the following qualifications. So can you explain how solar energy affects the Earth's surface? Can you describe and cite the causes for the development of climate zones? Can you explain what causes seasons? Can you describe how geography can impact climate? And can you explain what causes El Nino and La Nina and describe the impacts that they have? I hope you can complete all of those parameters, and I will see you in class soon.